Hey everyone, welcome back to Dev Parkour. In this video, I want to talk about why the output of your parsers should be abstract syntax trees. While it might be tempting, especially with very simple parsers or very simple applications where you're writing a parser, to just write your output as you parse, or in the case that usually a calculator example is one of the first examples you work through when you're learning parsers. It's very tempting to just do the math as you parse. And in some applications that might work just fine. However, the reason that we use an abstract syntax tree is because it tends to be easier to solve the more complex problems when you do kind of a two-phase. I'm not going to say two-pass because there are actually types of compilers that are called two-pass compilers, and they do two passes. And one of those passes is actually building the abstract syntax tree, and then the second pass is something totally different that we're not going to talk about in this video. So I'm going to call these two-phase approaches, where phase one is building up the abstract syntax tree, and then phase two is taking that abstract syntax tree and generating your output, your actual output, for your particular problem, or performing some computation, calculation, some operation. In my case, in Yade, and in the example that I used at the beginning of this week, my end goal was actually outputting or getting the description of a table. I'll just call it that, because the what it actually does with that is kind of inconsequential to the parsing activity. That's just more generally the piece of software, what it does. So phase one is reading in the SQL statement and parsing that to an AST. So in my case, I have a specific object called statement. It's a describe statement, and it contains the table. I think I talked about that in yesterday's video. And then phase two is taking that and actually looking up the table, getting its schema, and generating it's a different data structure that I'm using. In this case, I think it is actually a result set, just like you would get for a select statement. But in this case, it contains the table name and the SQL that you would run to create the table exactly as is. And obviously, because I'm running on flat files and I don't have indexes and things like that, I'm taking some liberties with that create statement. It is legitimately a create statement that would create the table exactly as it exists on disk. But the reason I implemented this statement was more so that if tools like HeidiSQL, I think, uses that. If I wanted to connect HeidiSQL to a Yade server, I would want something that HeidiSQL could do something reasonable with, so that it wouldn't just send that SQL statement in and then bomb because it didn't get the response that it was expecting. That would be more frustrating than anything, and I didn't want to deal with that. I think ultimately my goal with Yade is to run WordPress on top of it. I believe that WordPress also uses the describe table statement extensively as well. So, I wanted to support that. So, getting back to the topic at hand, why do we use abstract syntax trees as that intermediary? Why not something else? Well, the abstract syntax tree, by its very nature, is an object-oriented or structured representation. You don't have to be using an object-oriented language. You can use C even, but it is a structured representation of the input and its various component pieces and how they relate to each other. So in a previous video this week, I mentioned you might have a method that has a collection of statements, and then you might have an if statement, and it has a condition, which is actually an expression. That's not a statement, but that's still a piece of syntax. And then within that expression, you might have terms and comparisons, or terms and operators, or something like that. You can further decompose conditions into component conditions. Perhaps you have Boolean operators in there, ands and ors, and in that case you have a top level condition, and then it's a compound or a complex condition that has a left side and a right side, and then the combination operator, and, or, not, those sorts of things. So you can build up this tree, and it is a tree because we typically have nesting within programs. It's just the nature of how we've written programs, either by virtue of parentheses or by braces, curly braces, brackets. Any sort of punctuation generally is a form of nesting, except the semicolon. The semicolon tends to be a statement terminator, statement terminator. But all the other punctuation that I can think of tends to be some form of nesting or some form of further clarification. It's another level deep. So even if you get into things like generics, or C++ calls them templates, and they work a little bit differently, but let's stick to generics. You have a type, and that's a token, that's a thing in the AST. It's type annotation, and it has a placeholder, right? There's a reason they're called type arguments. There's a placeholder, which is another layer of nesting. So anything within that angle bracket is something that's contained within the top level type token. And of course, that type token might be part of either a parameter or a method signature, or return value, or type variable declaration, or something like that. That's a thing within the grammar that you're parsing. And then once you have this tree, doing anything with it is pretty straightforward. It's just tree operations. You start at the root node and you can traverse it. If you want to iterate over top level statements, you can do that. All the top level statements are children of that root node. If you want to find a particular method, you can look for all nodes that are methods in the tree, and then do whatever you want with that method. If you want to convert that to a different output format, say you're compiling and you need to turn it into machine code, well, that's fine too. You just go over each node in the tree and perform whatever operation is necessary to turn that into machine code. If it's a simple expression, then it's just a matter of converting that into the relevant machine code. If it's a complex expression, an if statement, that sort of thing, you typically would convert the children into machine code, possibly with some relative references, because you don't necessarily know where that code is going to end up. And then you stick it in placeholders of kind of a template for, this is the machine code that we write when we're writing out an if statement. And by doing that, you can basically gradually make this tree smaller and smaller, and replace, you probably wouldn't replace in memory, but conceptually you'd replace nodes, kind of going node by node, with the relevant machine code. And then at the end, you would have one big long string of machine code that you could write out. By doing it with an abstract syntax tree, it's a lot easier to reason about what you're doing and kind of prove that it's correct, and even write unit tests on it. Back in the day, unit tests weren't really written for compilers and parsers, so it was really important for this stuff to make sense and for people to be able to reason through it. But now that we do have unit tests, it's still important to do this, because it means that we have very specific points throughout the implementation of our program that we can invoke unit tests. So we can run the specific components the way we want to, and test out, does this if statement, does an AST, a mini AST representing this if statement, result in the machine code that I expect, that sort of thing. So that's what we're getting at when we talk about ASTs and why we use them for parsers. So hopefully you found this video interesting. If you did, go ahead and hit that thumbs up button. If you haven't already, please subscribe to the channel and click that notification bell. I really appreciate that. I love watching you all watch my videos and learn, hopefully learn a bunch from them. If there's more that you want to learn, more that you want me to talk about, or if you have any thoughts or questions, go ahead and leave them down in the comment section below. Another thing I enjoy about this channel is being able to read all the comments and respond to them, and get to see you all getting engaged in the learning process. So really excited about that. Got some cool videos coming up. Tomorrow is a special day, so stay tuned for that. I will see you tomorrow. Thanks for watching.